Assemble the pieces, attach a 10 ml syringe to the top port, and attach the setup to the PES port of the C6 ventilator. Notice the stopcocks is different than normal stopcocks. The arrow indicates which sides are open. In this example, Pete has changed the stopcock to be open to everything: the vent, the syringe, and the balloon. Here, Pete is attaching the setup to the balloon. Right now, the stopcock is open to everything. Pete has attached a 10 ml syringe and turned the stopcock so it's open to the balloon and the syringe. After injecting 6 ml of air, Pete withdrew 2 ml and turned the stopcock off to the syringe. On the vent, select Graphics and then change to Layout 1. Replace the volume waveform with the esophageal waveform and insert the transpulmonary waveform to the open slot. Note the esophageal waveform. We should see cardiac oscillations if we're in the correct spot. To confirm placement of the balloon, we're performing an occlusion test. Perform an expiratory hold and then push down on the patient's chest with a consistent pressure. Identify a baseline value and a high point value on both airway and esophageal waveforms. Subtract the high point value to the baseline value and then divide the airway difference to the esophageal difference. The value should be between 0.8 and 1.2. The gold standard of esophageal balloon conformation is the chest X-ray. Look for the radial-opaque square to be just below the carina and above the heart. To find the transpulmonary PEEP, perform an expiratory hold. Subtract the airway pressure to the esophageal pressure to find our transpulmonary pressure. In this example, our esophageal pressure is 15 and our airway pressure is 5, so our transpulmonary PEEP is -10, which results in airway collapse shown in our model. Pete increased the PEEP by 10 to match the transpulmonary PEEP, and then performed another expiratory hold. The results after our change is airway pressure is 15, the esophageal pressure is 15, so our transpulmonary PEEP is 0. You can see the recruitment occurring in the model now that the transpulmonary PEEP is 0 and above. Ideally, we want the transpulmonary PEEP to be between 0 and 5 centimeters of water. Now we're going to find the transpulmonary plateau. Perform an inspiratory hold and then subtract the plateau pressure to the esophageal pressure. In this example, our plateau is 21 and our esophageal pressure is 15, so the transpulmonary plateau is 6. In this example, since the transpulmonary plateau is 6, Pete increased the tile volumes to provide more ventilation and then recheck the transpulmonary plateau after the change. Overdistension of the lungs occurs at the transpulmonary plateau greater than 20. After getting the transpulmonary PEEP and plateau, remove the air from the balloon and cap the esophageal balloon port.